amazed and astonished. Problem is my console's got springs with no polish. I spin up fast and impress with every request. I'm rock solid, my security is tight. Each function has a role. I give you some control, power to scale, unimpeachable. Only 5 years old, but my tech is stronger. And now that my timeouts are longer, I conquer every problem, every limitation, every situation. Think I have an integration, set functions for orchestration. The plan is to put your service to shame, but damn, reinvent's close. So let me spell out my name. I am the LAMBDAC. This is what I meant to be. Just a function that lets events trigger me. Meanwhile, Hacker News keeps throwing shade endlessly. Essentially, they treat me like PHP. A new CGI bins what they think of me. But with their blinded eyes, they fail to see there will be a serverless revolution in the century.
And to me,
He says asynchronously. Don't be shocked when TechCrunch mentions me. I will replace your service, set your workloads free. If need be, you can provision my concurrency. I'm gonna reduce your ops. I'm gonna reduce your ops. Hey yo, I'm unlike containers, no pods or orchestrators, and I'm gonna reduce your ops. I'm gonna reduce your ops. I'm gonna reduce your ops. Hey yo, I'm unlike containers, no clusters, noisy neighbors, and I'm gonna reduce your ops. I'm gonna reduce your ops. I dream of life without Apache. No more log files piling up endlessly, or changing Nginx configs haphazardly. Lambda and I have some really good chemistry with my ops. My scale's unprecedented. I'm the best no SQL DB ever invented. My queries are fast and I blast. My data's stable. Ask Rick Houlihan what I can do with a single table and reduce your apps. But apps will never be truly free until all events can be routed reliably. Send them to me and you'll see I'll handle events in mass. Even replace web hooks from your SaaS and reduce your apps. Genius, but think how you sell it. Ops needs to agree when devs start to compel it. I'm with you, but your position needs thought. You have a fine line to be walked. Threaten jobs, you're gonna get blocked. Werner, check what we got. This DynamoDB scales your data a lot. API gateway is hot. EventBridge, I like you a lot. Together we can build apps where the servers are not. We have resilience and redundancy all in one spot. We change paradigms and minds whether you like it or not. A revolutionary serverless event-driven services. Get out your credentials, show me where your cloud formation is. Oh, is my Twitter too loud? Sometimes my DAs get excited, shoot off at the mouth. My community is amazing and I promise that I'll make y'all proud. Let's get this guy in front of a crowd. I'm gonna reduce your ops. I'm gonna reduce your ops. Hey yo, I'm unlike containers, no pods or orchestrators, and I'm gonna reduce your ops. I'm gonna reduce your ops. I'm gonna reduce your ops. Hey yo, I'm unlike containers, no clusters, noisy neighbors, and I'm gonna reduce your ops. Everybody say, oh, 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 hey, whoa, 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 don't let him scare you. Let's go. Oh, oh, oh. I said we breathe when the service stops. I said breathe when the service stops. Oh, come on. Come on, let's go. Scale up when your traffic increases. You scale up. Tell your application it's gotta scale up. Tell your database it's gotta scale up. When are these companies gonna scale up? 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 Scale up. I imagine outages becoming just a memory. No alerts from me. In your sleep the weekend ahead of thee. And did you know the fact that all my apps are multi-AZ, distributing load and requests with full redundancy? Some misused cases, but not many. Of course, we've got serverless haters by the plenty, cause we scare peeps living in the past. We contrast, we're growing fast. Gotta get woke, it's 2020. Scratch that, terminate your service, join the movement. Soon Amazon will wonder where all the EC2s went. Foes oppose as we scale with the demand. No pods or jobs to maintain or understand now. Think about that independence, freedom to work on the customer experience, or will you stay in an endless cycle of patching, reacting, and tier 1 support dispatching? I know all this stuff with K8 is exciting, but damn, between the hype and the buzz, I've been bottling lightning. I got SAM layers, Lambda destinations. You want state EFS integration. I'm past patiently waiting and passionately surpassing the expectation on every single implication. The old way of building has no time left to borrow. I'm the power all the apps of tomorrow. And yeah, now I'm gonna reduce your ops. I'm gonna reduce your ops. Hey yo, I'm unlike containers, no patching, no maintainers, and I'm gonna reduce your ops. I'm gonna reduce your ops. We're gonna scale up. I'm gonna reduce your ops. It's gonna scale up. I'm gonna
Hello, hello everyone. Hope you guys enjoyed the video. So, good morning, afternoon, and evening to all of you out there. Welcome to our first AWS Cloud workshop, serverless workshop. And here, while we're just presenting, if you have any questions during the workshop, feel free to put your questions in the chat box on the right side or the Q&A in the bottom of the page. So let's get right into it. Let me introduce the team here. So I'm Reynold. I'm the Cloud Solutions Architect in MegazoneCloud, and I'm also an AWS Certified DevOps Engineer. And also I have my colleague here, Jason. So Jason, maybe you can introduce yourself a little bit more.
Hello, I'm Jason. I'm the Associate Cloud Engineer here, and I'm also an AWS Certified Developer.
Awesome. So before we move on, we want to talk more about the agenda. Firstly, we're going to talk about the company introduction, talk about introduce a little bit about MegazoneCloud, and we're going to discuss about what is serverless, why serverless, and finally we're going to show the demo. And if you have any questions, then we're going to have the Q&A session after the demo. So before we deep dive into the workshop, let me introduce who MegazoneCloud is. We are the largest premier partner and managed cloud service provider of AWS in the Asia Pacific region, with proven competencies and migration, especially in SAP and on the AWS, financial services, and more. We're from 2012, and we have won 3 AWS Partner of the Year award in 2016, 17, and 2021. We have also won the Partner of the Year in the Asia Pacific region in 2017. So when customer ask about what MegazoneCloud delivers in a perspective of the customer value, we summarize our offering as iPad. So iPad as in infrastructure, platform, application, and data. Our offering has been evolved along with the changing customers' requirements. In early 2012 and 13, most of the customers' requirements are focused on delivery of the infrastructure CDN, database, and also security. As the maturity of the cloud adoption is increasing, the customer is demanding more into the DevOps and data management platform. And as the large enterprises are adopting cloud, the demands of application increases, like such as ERP and CRM applications. We found that more and more customers' demands of using cloud were gathered around taking advantage of exponentially increasing data that are generated from their businesses. We also have a separate data management center team, which is focused around providing big data analytics, AI, machine learning, and the others. And on top of the 4 iPad pillars, we provide consulting, optimization, and managed services. And we also collaborate with our ISV partners to provide SaaS products based on customers' needs. As you may all know already, MegazoneCloud is headquartered in the capital city of South Korea, Seoul. We also have regional offices across Asia Pacific area, including Hanoi in Vietnam, Hong Kong, Shanghai in China, and Tokyo in Japan. And of course, we are currently broadcasting from the MegazoneCloud Hong Kong region. And also in the US, we have our North America presence in Palo Alto and Toronto, where we focus our service delivery, including 24/7 operations. And because we have 10 years of building the cloud business, our customer ranges from small startups, mid-sizes companies, and large legacy enterprises, as well, who actually are transforming businesses into the cloud native. We can proudly speak that we have grown with successes of more than 5,000 plus customers, including Samsung, LG, Lotte, and the others here. Awesome. Let's talk about what is serverless. So let's deep dive into what is actually serverless. You may be wondering what it means by serverless, right? Does serverless equals to no servers running? Or how expensive is it? why do we have to go for serverless? And is it easy to build? So if you have these questions in mind, you're definitely in the right place. So let's look at the analogy for serverless. Let's say, if you want to go for a meeting place, there are two options you can go for. It's either you rent a car or maybe you rent an Uber through a mobile application. So renting a car is like serverful computing. You'll need to rent and pay for the whole day. You also need to refill the fuel, find parking lot for the car, and once you have finished using the car, you'll need to return the car back to the rental place. So let's talk about Uber. Uber is like a serverless computing. It simplifies transportation. So you don't need to know how to operate a car, or you don't need to know how to get to the hotel, finding the path. You just call the Uber driver and say, hey, I want to go to this meeting place. And then you just have to pay for the amount of miles you drove. And it could be potentially much more cost effective. So for years, your application have run on servers, which you have to patch, update, and continuously look after late nights and early mornings due to the all unimaginable errors that may break your production environment. As long as you manage them, the whole responsibility of their function is on you. Serverless tends to be different with serverful application. You no longer need to worry about the underlying servers. The reason is that they are not managed by you anymore. And with management out of the picture, the responsibility falls on the cloud vendors. In this case, AWS. Well, serverless is all good, and maybe you're thinking that serverless can replace serverful. That's definitely not the case. Both serverful and serverless application can be run together depending on the use case and the application requirements. So let's see some of the use cases here for serverful and serverless. Serverless can be for short-lived workloads because most of the cloud vendors' serverless compute functions has a maximum runtime of less than half an hour. Some of the examples are like REST APIs to call your backend services, or maybe an event-driven architecture to process your credit card payment. For serverful, it's definitely a long-running workloads. So an example is like a AI to train your machine learning model, or let's say a batch processing that can run hours or even days. Another suitable workloads is unpredictable usage, because serverless has automatic scaling. So one of the examples is that an expanded Internet of Things. So if there are a lot of IoT devices, serverless is the way to go. And also for a video streaming website, like let's say Netflix. In comparison with that, predictable usage is mostly for serverful. By knowing the usage, you can configure and set up a scaling plan depending on the incoming traffic. Examples are like, let's say you have you are hosting a blog post website or a simple e-commerce website. So now we know what is serverless. Let's discuss about the why serverless. So there is actually three main benefits of serverless. Firstly, serverless helps you to offload the server management to the cloud vendor. In serverful environments like virtual machines, you need to provide and configure and update your operating system, application, and security patching. In a serverless environment, you do not have to think about the security and patching because it's all already managed by the cloud vendors. Next benefit is the independent scalability. In a serverful environment, you need to design the scalability depending on the incoming traffic for, let's say, peak hours and peak seasons. But for serverless, you do not have to worry about this. The compute environment will scale depending on the number of incoming traffic coming in. Finally, it is the pay for value. For serverful, you will need to pay for the resources even though there are no traffic coming in. But for serverless, you only have to pay for the number of traffic that are coming in, which means that even though there are no traffic, you do not have to pay for anything. So let's deep dive into what is offload server management. As a developer in serverless, your focus for managing infrastructure is only 10%, and you can focus your other 90% on building your application to achieve your business goals. So one of our customers who have moved from serverful to serverless consists of only 3 developers. The handling of the patching and updates are very difficult for them, as they do not have time to manage the infrastructure and would like to focus more on the application. So our team helped them to modernize their application through our consultation and help them to achieve their business goals. Right now, they are able to run their application without worrying about having to configure and update security patches and maintenance. Let's deep dive into one level deeper. If you see here in the left side for the architecture, we have a client that requests to the load balancer. The load balancer will distribute the request to the web servers and will query the MySQL databases. So what do you need to manage here as a developer? If you see the diagram on the right, AWS, which is highlighted in yellow, will manage the hardware, storage to the virtualization. Meanwhile, you need to manage the operating system, like you need to choose either Windows or Linux. The runtime, are you going to use Python or Java? And finally, you need to manage the code itself. So let's look at serverless. If you see the architecture here, the client will send requests to the API gateway, and it will route to the compute functions based on the routing path. The compute functions will get query or insert data to the serverless database. Then what do you need to manage? You only have to manage the code. So all of this, the operating system, runtime, and application are all offloaded to the cloud vendor, which is in this case AWS. So let's look at the second benefit, which is the independent scalability. For this scenario, let's say you have a web server that contains read and write API to the MySQL database. And let's say the write API have a lot of incoming requests coming in. You'll need to scale the web servers, including the read API. This is called the server-based scaling, and usually it's not resource efficient. You also need to create a scaling plan based on your incoming traffic. So for serverless, let's say there are a lot of traffic coming in for the write API to query the serverless database. The write API will automatically scale based on the number of requests, and you do not have to worry or plan or predict the prediction for the scalability plan. The final benefit is the pay for value. So if you see here on the left side, there's an elastic compute cloud, which is virtual machines that you need to pay per hour. And on the right side here, there's Lambda, which are the AWS compute functions that pay per request and execution time. So let's take a look at this graph. Let's say this graph is 24 hours. Even though there are no traffic, you will need to pay the virtual machines that are running. But for serverless, it really depends on the number of requests and traffic coming in. You only have to pay per request, and if there are no requests, you do not have to pay for anything. So now we know about what is serverless and why serverless. I'll pass this mic to Jason, and Jason will show the demo for serverless. So it's yours, Jason. Stage is yours.
Thank you, Reynold. So now we know what is serverless and why do we use serverless. So let's look into how do we use serverless. So before starting everything off, I would like to show you a video first, and then I will just make a quick summary on what it's talking about. So in this scenario, we're helping a startup to build a serverless web application, while this web application is about transportation leveraging unicorns. So let's go to the video.
In today's fast-paced world, everyone has places to be but not enough time in their jam-packed schedules. Introducing Wild Rides, a new innovative unicorn transportation service that helps people get to their destination faster and hassle-free. You simply open the Wild Rides app, request a unicorn, and then wait for the nearest unicorn to arrive and pick you up. It's better, faster, safer, and more magical. With fresh venture capital funding, Wild Rides is seeking talented engineers like you to help build its platform using Amazon Web Services. Wild Rides technology platform will be built using serverless architectures with services like AWS Lambda, which lets you run code without provisioning or managing servers. Hop on board and help Wild Rides build the future of magical transportation by joining one of our free guided workshops in a city near you.
Okay, so as is shown in the video, we are going to help this startup to build this application, which is going to leverage Unicorn. So it's like a virtual Uber service here. So let us go deeper into what has been happening in this application. So I will make a quick summary here. For example, you can see here, there's the map here. And then if you want to go to like Capitol Hill, you need to click on the tag on the location first, so to indicate the location, and then you click on this request unicorn button, and then the unicorn is going to fly to that exact location. In the meantime, this record will also be saved in the database. So you can see here the unicorn is going to the location in the lake, so we're going to request another unicorn, and it's there. So let us go deeper into the architecture itself. So as you can see here, it consists of, firstly, the front end and authentication. So AWS Amplify is handling the static web hosting, while AWS Cognito is handling the authentication. The second part of this architecture is going to be a REST API backend, which consists of a REST API gateway, Lambda, and DynamoDB. So in this workshop, we'll be also using AWS SAM, which is an infrastructure as code tool, to create a new API, which is going to get the records that you have requested unicorn. And this whole architecture actually is also built by using AWS SAM. So let's go one level even deeper into the whole application. So AWS Amplify is a fully managed web app and static web hosting service, which is also an open source framework. It helps simplify configurations by a built-in CI/CD pipeline and having a visual development environment. So it's something like a VS Code here. While AWS Amazon Cognito is a managed sign-up and sign-in access control service. So it allows like identity federations. So the good thing about Cognito is it has no infrastructure provision overhead. So the meaning is this. So you don't need to manage like an access control server, something like an Active Directory. That part is actually managed by AWS. So the second part is the REST API backend. So the first thing I'm going to introduce is AWS Lambda, which is a serverless compute service. And the good thing about Lambda is you only need to upload the code, while the operation system and the servers, even like scaling, everything, configurations is managed by AWS. You only need to go into create the function. You just put the code there and everything is done. So AWS Lambda, how AWS Lambda works in this architecture is it serves as the handler equivalent inside a web server. So it's the part where the event handler to handle the request, while the second component is the Amazon API gateway. So it is the management service. It also serves as the routing mechanism inside a web server. So when traffic goes into the backend, it will firstly reach the API gateway. Then the API gateway is going to route based on the request to that designated Lambda, and then execute the function and shows the response. So the final component here is DynamoDB, which is a fully managed serverless key value NoSQL database. So the good thing about DynamoDB that instead of traditional NoSQL database, it has built-in security and it has continuous backups. It also has automated scalability and availability. Also automating like multi-region replication, which means that you can do disaster recovery pretty easily. So the final component here is AWS SAM, the full name being Serverless Application Module. So it's an open source framework infrastructure as code extension from another IAC application, which is named CloudFormation. So it's specialized for Lambdas or API gateway. So if you're familiar with AWS services, there's another way, a traditional way to build architectures, which is through the AWS console. For example, you're building a EC2 or like a Lambda, you just go to the console and then just click the create that function, create that service, and then everything is done. It may be easy for building like an individual service, but as AWS is managing the console service by service, in which if you're building like an complicated architecture, it's going to be very hard to manage everything because you cannot. It's much harder to keep everything consistent. But the great thing about AWS SAM is this: so you just put every configuration inside a JSON or a YAML file. So you can see here, you just put the code here, and then everything is shown in one file, which ensures that consistency. Also, it also helps like to deploy everything once and for all, because through the console, you need to go through many steps and many clicking, while through serverless AWS SAM, you just need to run a command and everything will be done once and for all. So let us go to the demo, which is going to show you now. So you can see here, this is the serverless one. This is the Amplify website. So I'm also going to send it through the chat box, so which you can access and then to taste it out how it's working here. So we just skip it up here, and then we're just going to go for the registration process. In here,
so you guys can also click the link in the chat so that you guys can join the demo also. Yeah.
Yes. Thank you, Reynold. So to register here, you just need to enter your email and the password you want. Also, as a reminder, the password need to be at least 8 characters here. So what has been done here is this. So after I send this registration button, and then Amazon Cognito will recognize the registration. So let's go to Cognito, and there's like estimated number of users, which is me in here. So which is unconfirmed because I haven't sent the verification code to AWS Cognito here. So we just send the verification code. And then now we can do the login here. So let's have a small recap on what has been done in this Wild Rides web application. So for example, if I want to go to Seattle, we'll just click on this location here, and then just click this request unicorn button. Then the unicorn is going to go to that location. So feel free to click it out and try it out. So the back-end logic about everything here is this. So when you're clicking this request unicorn button, it will send the request to the API gateway, and the API gateway will route based on the request to the AWS Lambda. So you can see API gateway is here. You can see there's this -ride path here. So this path is going to route the request unicorn request to the request unicorn function shown here. Wait a second. So the registration button is in the Gibby up there. So after you go to the website, I'll just have a show here. It's this Gibby up button here. So let us continue. So this write method here is going to route the request to the request unicorn function. So one thing which is great about Lambda, why it's offload server management is this. So the only thing that you need to do is to just upload this backend code, which is the request unicorn code here. So you can also do it on the console. You can just like go to create the function, and then you just name the function name like get unicorn, and then you just upload your code here, and then everything is done. Pretty easy, right? So let's go back to the code here. So after you execute this code, it's going to respond by sending the animation that the unicorn is going to this certain destination. And then it will also save the record inside DynamoDB. So we just explore the items here. And then this right table is the DynamoDB table. So you can see here, there are already 3 records here, which indicates like it already has 3 times the request unicorn has been invoked. So let us invoke one more time by sending this request unicorn. So now we'll just do a refresh here. Yep, and then yeah, there's more items now here. So I would like to ask one question. So how do we show all of this data? How do we show all of this record back to the customer? So there are 2 steps to partake here, right? So as we're doing this fully serverless, the first thing we're going to do is to create a new Lambda function, which is to get the history records. Then the second step is to update the API gateway to add a new path, which is going to get the history. So there are 2 ways to do here. Firstly, you can go to the console. You can just create the function, and then you can just input like history. But this is going to be a little bit redundant, because you can see here, AWS manages everything, service by service, in which the Lambda console panel is different from the API gateway panel. So we will do this in a more efficient way, is through the leveraging of AWS SAM. So to add this history button, the first thing we're going to do is to do a little bit change in the front end. So we just enable and check history button here. Then we will just commit the changes and then deploy. So now let us go back to the Amplify and see what is happening. So now you can see here, AWS Amplify is reprovisioning and deploying everything again. So what is happening behind back there is this. AWS Amplify is leveraging something called code commit. So this code commit is an AWS equivalent to GitHub, which is used for version control and as a repository for your code. So after I do a git commit and then git push to this code commit, AWS Amplify is going to sense that, and then it's going to rebuild and redeploy everything. So as a result here, you can just do like an update to the code, and everything will be redeployed to the front, up front. So as a result, I would also say like AWS Amplify has this built-in CI/CD, which is very useful because you don't need to do that redundant deployment step that you need to go to access inside the web server and then just to change the code. So meanwhile, while we are waiting for this deployment process, we're also going to change the backend. So the thing we're going to do here is this. So we're going to upload this history.js, deploying as a Lambda, and then to map it to the API gateway. So the first step we're going to do to make it a Lambda function. So this code is, firstly, it's specifying the type here, which indicates that it's calling AWS Lambda. Then it's also configuring the handler mapping to the history.js here. So it also names the function name getHistory. It also sets the memory size and timeout, also the runtime. And it also gives it a policy, which is going to give this Lambda function and the access right to DynamoDB. So it allows it to read the DynamoDB and then get the records and show it back to the front end. So it works like an IAM role attached to an EC2 if you're familiar to AWS. So it's just a role here. So the second thing is it is done. It also specifies the events, which is going to map to the API gateway with the path history. So the second step here we're going to do is to enable the configuration for the API gateway. So what has been done here is this. So firstly, we specify the path, which is, Firstly, we specify the path, which is -history, which maps to the Lambda function in the event API configuration. And it also specifies the request type, what is going to be post. And meanwhile, we're also using a Swagger template to build this API. So in Amazon API Gateway, you can actually customize your configurations to build the API because we're using a Swagger template. So as everything has been done here, we'll just proceed to the deployment. So the first code we're going to run is going to be SAM build. So what this SAM build is doing here is it's going to read the template.yaml, and it's going to locally build and then to test this function to see if it is workable or not. So the second step we're going to do here is do a SAM deploy. So this is the official step to bring this configuration to the AWS application. So you can see here that it is starting to deploy the stack, which is going to be SAM app. We're also deploying in US East 1. And then you can see the change stack here. So as we're only updating the API gateway and creating a new Lambda function, so it revolves around adding the new Lambda function, giving the IAM role to access the database, and then to modify the API gateway to give it a new method request there. So we're going to confirm the changes by clicking Y here. As you can see here in the create in progress, the DynamoDB, the AWS SAM is starting the deployment. So while we are waiting for the deployment, let's check the front end results. So we'll just re-enter the routes again. So instead of having only one button, you can see here there's another button which is called check pickup history. So the changes have been done here. So you can see that I commit and then push the changes. Everything has been automatically deployed. But keep in mind that this button is not going to work just yet because we haven't finished the deployment of the backend. So now let us go back to the backend and then see if everything has been done. So you can see here, everything has been successfully updated. So we will go back to the front end and then we will validate the changes. So we just open console. And then we can check our pickup history here. So you can see here, it shows everything that is inside the DynamoDB. So you can see there are like 8 records here. Corresponds to DynamoDB. Let me have a refresh. Corresponds to the DynamoDB. It's going to have 8 records here. So what if I request another unicorn? So now it's going to show 9 records. So in conclusion of today's workshop, we have learned about like what is serverless and the difference between serverless and serverful and the benefits of why we're using serverless, because it really helps offload that server management a lot. Like you only need to manage your code and you don't need to do like the operation system patching. You do not need to manage security. You don't even need to manage like access controls or APIs or partitionings or like patching. So we also learned how to build a serverless web application, in which the front end is consist of Amplify and Kignito, while the back end being REST API, Lambda, and DynamoDB. The third and final thing we have talked into is by leveraging AWS SAM, we can deploy a large application once and for all, while maintaining that architecture consistency. Instead of using directly through the console, we're just going to go through service by service and through the clickings. So this is the end of our today's presentation. So thank you for your joining. So if you have any question, feel free to leave it in the chat box. So we will now go to the Q&A section.
So guys, could you please fill in the survey link? Also, if you have any questions, just put it in the Q&A. And please scan this barcode so that you can fill in any kind of maybe feedback. So we're happy to receive any feedback so we can improve our later on workshop. So yeah, let me see the question list. Okay, I think I got few questions here. So the first question is one of the questions is what is the relation between serverless and event-driven architecture? So maybe I'll just explain a little bit what is event-driven architecture. Maybe you might know it's a decoupled service that handles you could say in real time event, right? So it's event-driven. So events like HTTP requests or any kind of a cron job can be an event. So why do we maybe you're wondering what's the relation, right? First thing is because of its benefits on offloading the management workload. Like, as you may know, serverless helps to offload all of those management workload to the cloud vendors. And creating the event-driven architecture is much more simpler and easier using serverless, especially using AWS SAM. So using the normal architecture, you need to, you could say, patching, security, all those things. So it's really hard to build and maintain. So that's why serverless and event-driven architecture is a really nice pair together. Yep. So let's see. What is the difference between container and serverless? Okay, so maybe you guys are thinking container, you could say container is where you need to, because you could say it's almost serverless, but that's definitely not the case for some of the container services like Kubernetes. You need to provision EC2 and containers, so you still need to manage the application. You don't have to manage the operating system, of course, but the application, you need to manage it, right? Like which dependencies you need to install and all of those things. So, but serverless, it's much more different than that. It's all of those things are already managed, and you just have to manage the code only. So container is you need to create the Docker and all those things. So that's the difference, you could say, for container and serverless. Yep. Are there any more questions from you guys? So if none, then maybe we'll just wait for a bit and you guys can fill in the survey link. Yep. Okay. Then I think that's mostly it for today. So thank you very much, guys, for coming to this workshop. Really appreciate it. So we'll be having more and more workshops in the coming, in the near future. So look forward to that. So thank you very much, guys.
Thank you.
Thank you. Bye-bye.
Bye-bye. Have a nice day.